Okay, so now that we've defined economic cost and economic profit, which is it's your explicit cost accounting for opportunity cost, and your profit accounting for opportunity cost. And again, this should be in the back of your mind for all decisions that you make or that you see in this class. At any rate, now that we've defined that, we can move on to the production possibilities frontier. And as I kind of hinted at, it's just a way of graphically representing a production pattern in the most efficient way, or the most efficient production patterns, basically. So here's the formal definition. A production possibilities frontier shows the maximum quantities of outputs that it is possible to produce with a given set of resources. Okay. This will probably make more sense when we dive in an example, but basically you have a given set of resources. It could be money, it could be raw material, it could be time. So I have a given number of aluminum. How do I use that to make Coke cans versus Pepsi cans? Or I have a given amount of time. How do I use that to make lectures versus servicing nonprofits? Okay. That would be your production possibilities frontier. It's a way of graphically representing the choice you have between making those two goods and the most efficient way of doing it. And it'll make more sense as we do the example. So let's dive into that example. Okay. So we have this guy, Marshall. He works at a factory building cars, but he can also write music. This is based on the movie 8 Mile. Okay. So Marshall has two skills. He works at a factory building cars. He can write music. So those are his two things, songs and cars, that he can produce. Okay. It doesn't have to be two things. It can be multiple things. But for the sake of this class, let's just restrict it to two. So Marshall can do two things, songs or music. Those are what he produces. He can build 7 cars a day or write 1 song a day, but he can't do both at the same time. So if he has a certain amount of time, let's say a day, he can do 7 cars, 1 song. Okay. He can do any combination in between. So he can do 3.5 cars and half of a song. And then, the next day finish off the other 3.5 and the other song. In this class, decimals are perfectly okay. Don't see a need to round to 1 car, 1 song, or 8 cars, 1 song, or 4 cars, 1 song, or whatever it was. In fact, I consider it wrong to round when you don't have to. If your final answer is rounded, that's okay. I'm not going to take points off, but rounding in the early steps will throw you off in the later steps. So don't generally round if you don't have to. Okay. Okay, so we're going to plot this production possibilities frontier for 1 week, and we're going to do it as a class. Okay. So I did have a blank book up, but all right. So I got this Excel file here, and I'm going to kind of bring it up a little bit, make it a little bigger. All right, so we have Marshall, and he's got 1 week, 7 days. Okay, so 7 days of song making and car building. Okay. So what can Marshall do in those 7 days? Okay, so we can have 1 day then we can have half days or whatever. But for this table, I'm just going to do it in discrete elements, 1 day each. Okay, so 1 day, I should start with 0 days, cars, 7 days, songs. So if you spend 0 days making a car and 7 days making a song, how many can you make of each? So I'm going to have cars made here. Oh, this is car mades. And songs made. Okay. Ah. Boy, do I miss whiteboards. Okay. So if Marshall spends 0 days making cars, he makes 0 cars. If he spends 7 days making songs, how many songs can he make? Well, that depends. How quickly does he make a song? He makes 1 song per day. So 7 days times 1 song per day equals, so the days will cancel out. Oop. I'm just going to make this way bigger. So days cancels out with days, because this will be in the denominator. 7 songs. Okay. What if he spends 1 day on cars? How many days does he have left to spend on songs? He has 6 days on songs. Okay. 1 day on cars, he builds 7 cars per day. So 1 day times 7 cars per day equals 7 cars. Again, the days cancel out. Should be pretty straightforward, right? Okay, how many songs does he make? So he spends 6 days times 1 song per day equals 6 songs. Okay, and then I'm going to drag this down. I'm going to do 2, 5, 3, 4, 2, 3, 1, 6 is, oh, I'm going the wrong way. So this would be 4, 5, nope, 4, 3, geez Louise. Okay, and this should be 5 days on cars, 2 days on songs, right? These numbers here should add up to 7 because he's got 7 days. His budget constraint is 7 days. And I'm going to add one more row. So if he spends 6 days on cars, how many days does he have left to spend on songs? 1 day. And if he spends 7 days on cars, how many days does he have left on songs? 0. So I'm not going to do all these, I'm not going to write out all the equations, it just follows suit, but I'll do one more set of equations and then we'll fill out the chart together. So I hope you're filling out along, or at least following along with what I'm doing. Okay, so if he spends 2 days, 7 cars a day, how many cars does he make? 14 cars. 2 times 7 is 14. Okay, so I'm just going to fill this out as with the multiples of 7. And then this will be, spends 5 days making songs. He has 5 songs. Okay, I'm going to fill this out with the multiples of 1. Okay. So if Marshall spends all of his days making songs, he makes 0 cars, 7 songs. If he spends all of his time making cars, right, he makes 49 cars at a rate of 7 cars per day, and 0 songs. And here are the other combinations of songs and cars he can make. So if he spends 4 days making cars at 7 days per car, 7 cars per day, he makes 28 cars. And if he's making 28 cars, he's only making 3 songs. Okay, given that we know the budget of 7 days, and we know the rate by which he makes cars, we don't need that first column. We just need the cars made and the songs made. Okay. So like if I gave you that Marshall made 38.5 cars. So 38.5, just so we can see it. We can backtrack the number of days he spent making cars. So if he makes so X days times 7. Let's do this on this one here. X days times 7 cars per day equals 38.5 cars, right? We're going to solve that for X. All we have to do is divide by 7 equals 38.5 divided by 7. So it should be 5.5. Okay. So if I know that Marshall is spending 5.5 days making cars, I know that he's spending 7 days minus 5.5, or we could do this algebraically. 5.5 days on cars plus X days on songs equals 7 days in a week. So X equals 7 minus 5.5 equals 1.5 days on songs. Okay. And then we can backtrack the number of actual songs that we make. So 1.5 days per song, days on songs times 1 day per song equals 1.5 songs. So given that I know that Marshall made 38.5 cars, I can backtrack that he made 1.5 songs. Okay? These are your actual production possibilities. Okay? So I'll give you one more. Let's say that Marshall spent 45.5, Marshall made 45.5 cars. Marshall made 45.5 cars. How many songs did he make, assuming that he's using up all of his time? Okay. So I would take the time out, pause the video, and solve it yourself.